All right, welcome to the homework video for 4.03. This is where we start doing a lot of translation. So the instructions say, define a variable and write an inequality for each situation. The first one says, Billy is going to buy at most 15 holiday tags. So the easy part is the let statement. Let's just say let x equal tags. All right, that's just whatever we're talking about. Now, what can make these things tricky is words like at most, at least. The way I like to do it is if the number they're giving me is 15, I write 14, I write 15, and I write 16. And then I ask myself, if Billy is at most going to buy 15, will he buy 16? No, because at most he's going to buy 15. Could he buy 15 exactly? Yeah, he could buy 15 exactly. Could he buy 14? Yeah, he could buy 14 if he only decides to buy 14. So that's telling me that I need the numbers that are less than or equal to 15. I'm not willing to go above 15. I want all the numbers that are less than or equal to 15. So when I write my inequality, that's x is less than or equal to 15. And just kind of writing out those numbers helps me sort of visualize what's going on. So let's try this again for number 2. Zach is going to buy gifts for at least 3 people. So we'll start with our let statement. Let x equal people, I guess in this case. So the number that they're giving us is 3, so we're going to write a 2, a 3, and a 4. So if Zach is going to buy gifts for at least 3 people, that's kind of telling me that 3 is the minimum number that he's going with. So he's not only going to buy them for 2, that wouldn't be high enough. He could buy them for 3 exactly, or if he's feeling really generous, maybe he'll buy them for 4 or 5 or 6, but it's going to be numbers that are larger than 3. 3 is the minimum. When it says at least 3 people, that's our lowest point, but it could be higher. So when we write this, it's going to be x is greater than or equal to 3. Okay? So those are the ones that use kind of at most, at least. These other ones are more like the ones that we used to do in the equation unit, where we have to keep track of kind of all the words and what they mean. All right, so this one says 5 times the difference of a number and 3 is less than or equal to 20. All right, so if we kind of go through this and break this down, all right, times is talking about multiplication. We've talked about difference of. Most times when we see difference of, we're talking about subtraction, but inside of parentheses. So what are we subtracting? Well, we're going to subtract a number, which is our x, and we're going to subtract 3, which is just a regular 3. So we've got 5 times the difference of a number and 3 is less than or equal to, there's our symbol. Remember, is used to be our equal sign, but now we have to keep reading. So this is our less than or equal to sign, and then the word 20 is just the number 20. Okay? So if we're doing this problem, we can say, all right, this is 5 parentheses x minus 3 is less than or equal to 20. All right? And now that we have this, now we actually have to go ahead and solve it. So we'll distribute to both sides. 5x minus 15 is less than or equal to 20. Add 15 to both sides. 5x is less than or equal to 35. I'm just going to go up here. So let me rewrite that. Divide both sides by 5. X is less than or equal to 7. Okay? So that's how we do one of those. Let's take a look at this next one. All right, twice the sum of a number and 7 is greater than the product of that number and 9. All right, there's a lot going on here. So twice, that's kind of like a combo word. It's not only telling us the operation, but it's telling us the number. We're multiplying by 2. When you do something twice, you do it 2 times. Sum of is kind of the cousin of difference of. It's going to be addition and it's going to be inside of our parentheses there. So what are we actually adding? Well, we're adding a number, which is our code for x, and we're adding 7. All right? Is greater than, so there's our inequality symbol. We want to make a greater than symbol. Remember, that kind of looks like a G if you add that little loop there. The product of that number and 9. So the key is remembering that product is multiplication. Now, if we did this in order, it would be x times 9, but usually when we write these, we put the number first, so this is really going to be 9 times x. And because multiplication is commutative, the order doesn't really matter. So if we write this out as one long inequality, it would be 2 parentheses x plus 7 is greater than 9x. Okay? So if we distribute here, 2x plus 14 is greater than 9x. Subtract 2x from both sides. 14 is greater than 7x. Divide both sides by 7. 2 is greater than x. Okay? Now, on this problem, we don't have to graph, so it's fine to leave it like this. But what I've found is that when you're graphing, it's usually helpful to have the x on the other side because it's a little easier to read. So if you're going to do that, just make sure you're paying attention to your inequality. If we look here, x is on, the technical term there is the pointy side or the less than side. So we want to make sure that we keep it on that side when we rewrite it. So we're actually almost flipping the inequality so that we keep the x on the proper side. Now again, for this one, because we don't have to graph, it's not really necessary, but it's a good habit to get into for when you're graphing. All right, we got 2 more on the back here. 4 less than a number is less than or equal to twice that number. All right, so here's where less than can get a little confusing. There's less than, which is our turnaround subtraction, and then there's is less than, which is our inequality. All right, so let's read this one again. For less than a number, there's no is there, so this is going to be our turnaround subtraction, where even though the 4 is here and the x is here, when we actually write out our problem, we're going to flip those around. Now here's the word is less than or equal to, so that's going to be our inequality. Twice that number, we said on the last one, twice is times 2, or 2 times, and then a number is just x. So we're left with x minus 4 is less than or equal to 2x. All right. If we subtract x from both sides, we're going to be left with negative 4 is less than or equal to. Now, minus x is really minus 1x, so 2 minus 1 is 1x, which you can write 1x, or you can just write it as x. X and 1x mean the same thing. And then, just like I said on the last page, we're not graphing today, but it's a good habit to get into, is get that letter on the left-hand side. And again, this is on the greater than side or the open side, so we want to make sure that it stays on that side. X still is next to the greater than or the open side, which is what we want. So this final way we could read this is x is greater than or equal to negative 4. Looking at the last one here, we have 12 more than a number is greater than 24. Okay, so more than, we have to remember, is addition. So we've got 12 plus a number is our code for x, is greater than, so the key here is just remembering which direction greater than is, just write like that, 24. All right, so our final inequality here will be 12 plus x is greater than 24. And then to solve this, we would just subtract 12 from both sides, and you're going to end up with x is greater than 12. All right, we don't even have to flip anything around here because the x is already on the left-hand side. All right, I hope this was helpful. Have a good day.